those who may not have attended one of these webinars before. Quick short introduction about the project location, and then we'll get into reclamation and closure plan, our objectives, goals, and strategies. Then we'll talk about a little bit general reclamation practices, things that happen generally on site. And then we'll transition into some specific reclamation and closure practices for each specific facility. And then we'll try to summarize it all in some quick distinct points. And we'll pause through each of these as we transition from section to section of this agenda to take questions. So feel free to throw your questions out in the Q&A box there, and we'll stop and let Shelley read those questions off to us, and we can tackle them as we go between sections. So let's jump right into our introduction. The Stibnite Gold Project is located in central Idaho, and as you see on the left side of the map here, you see McCall Cascade, and the star indicates the Stibnite Gold Project. And on the right side, a little bit closer view, you see McCall and Cascade here, and the Stibnite Gold Project is east of those locations, east and northeast of those locations. It's a historic mining district. Many have seen this slide before. Things started in the late 1800s and geared up in the 1930s and 40s as strategic minerals were needed for the war effort. Antimony, tungsten in particular, drove a lot of the mining activities in the early century. And then, of course, as World War II and the Korean War slowed, so did the mining efforts in that area. There was some periodic mining in the 70s through the 90s, and then things pretty much closed down by the 1990s. And then, of course, Midas Gold came along in 2009 through 2011 and started working on geologic evaluation and consolidation of land ownership. So Midas Gold has been working on the project in this area since about 2009. And as you see from this photo, there's a lot of legacy mining materials out there. And on this next slide, we see the existing conditions of all of the legacy mining facilities and features out here. And some of the highlights of this on the right side photos here at the top right, we see the Yellow Pine Pit with the cascade of the East Fork of the South Fork of the Salmon River. And as noted previously, one of the previous slides in 1938, when this pit opened up, that's the time frame when migratory fish passage was blocked. In this reach between Yellow Pine Pit and Meadow Creek, there's about 13,000 feet of habitat of the East Fork or the South Fork of the Salmon River that is poor quality habitat for fisheries and aquatic species. And notably, we have restorative and enhanced projects in our plan to help enhance those reaches. And in the lower area, we see this blowout creek at the bottom of the map. In 1965, there was an earthen dam that was breached and blew out, and continues to this day to contribute large amounts of sediment to Meadow Creek and the East Fork. And part of the plan of restoration and operations is to restore that and fix the sedimentation problem and restore that stream to a more natural condition. Additionally, on the left side of the screen, we have some historic spent ore disposal area. It's known as SODA, spent ore disposal area, as well as some tailings. The old Bradley tailings is underneath that, as we see in this photo at the top left. And so those are some highlights of historic legacy facilities that the Midas Gold Plan of Restoration and Operations will go in and help restore and reclaim. So we'll jump right into this now, the reclamation and closure plan. First of all, we want to be able to let everybody know what our goals, objectives, and strategies are in developing this plan. So we had a goal to do concurrent reclamation and restoration activities concurrent with the mining activities, and try to do as much of that early in our time frame of construction and operation as we could. And we felt like we didn't want to leave everything until after mining operations to do the reclamation, closure, and restoration activities. So that was one of our basic upfront goals and objectives. We also recognized that we wanted to stabilize all of the facilities of the mine and not pick and choose, but certainly stabilize and rehabilitate and refacilitate all of those facilities. Additionally, we recognize that control of storm and contact water was important, not only during operations, but through the reclamation and closure and restoration components of our activities. So we want to maintain that compliance with our surface and groundwater regulations through the closure process. One of our objectives is also to restore the Stibnite Gold Project areas to self-sustaining productive use. So we want these areas, and we've designed these areas to be self-propagating and self-sustaining, so they'll be of use, multiple use in the future. Additionally, we recognize that that protecting the public, the wildlife, and the environment during the construction, operation, and site closure processes is very important, and we've built those strategies and objectives into our reclamation and closure plan. And lastly, we recognize that it's important to learn as we go and manage our processes by adapting to those learnings. So this adaptive management concept has been built into our reclamation and closure plans as well. Here's a quick example of one of those strategies and goals, and that is to do upfront and concurrent reclamation and restoration. This is a snapshot of timelines of some basic activities that we have planned, and you see across the top here, these are the years of construction, operation, and closure from 1 to 20, and then on the left side are various activities, and a couple of these to point out that we will be doing early are things like the East Fork South Fork Salmon River Diversion Tunnel, which is construction year 2, and that establishes, not only does it divert the river so that the yellow pine pit can be mined, but it also reestablishes volitional passage for migratory fish very early in the process, and allows those fish to access additional habitat that they haven't had for, well, since 1938. We also recognize the removal of the spent ore in Meadow Creek Valley, the soda again. And we'll be reprocessing legacy materials, namely the Bradley tailings that's underlying that spent ore disposal area in year 4. So that's early in the process. Remove legacy development rock at Yellow Pine Pit and West End Pit. So those will be handled and removed and put in development rock storage areas. Also, we install and start working on this Blowout Creek problem that's been out there since 1965, early in our process in construction year 3, and stabilize that to controlled sediments early on. And as I mentioned before, the East Fork stream habitat and riparian enhancement areas is again early in our process in construction year 3. And we also note down here at the bottom that in these early years, we start doing things like revegetation burnt areas, as well as the wetland mitigation processes that will start early. And we also see that in some of these other years, we get some concurrent reclamation in years 14 and 11 and 14. There is, of course, as you can see on this chart, significant work that will be done post operations. Strategies, as I previously mentioned, adaptive management. In this graphic, we see somewhat of a basic understanding of the process of establishing a mining operation, where exploration, pre-development, permitting, and approval, which that's where we're at right now, and then that transitions into construction and operations, and ultimately this piece of the pie that's hanging out here is closure and reclamation. And of course, during construction, we will have construction oversight, management, monitoring, and documentation. And this is the learning part, where we start to understand how our plans are being implemented on the ground. And we want to learn and manage from that. And once that post-construction period is done, we'll be able to use those learnings to confirm and modify plans as needed. So as needed, we can modify our reclamation and closure plans and designs, schedules, and bond estimates based on things that we've learned through construction and operations, and ultimately have better plans and plans that have been adaptively managed for closure. So that's a quick snapshot of goals, objectives, and strategies. Let's take some questions if there's any. Shelley?
Thank you, Dan. I know we have been up at site for quite a few years now. How much reclamation have we done so far, if any?
We have done more of tree planting and sediment control than larger reclamation projects at this point. So we have not done a lot of reclamation of existing facilities, because this bigger plan of the reclamation closure, the PRO, it encompasses all of these things in a bigger way that will be more restorative than the smaller components of doing little piecemeal reclamation projects. So our focus has been sediment control and reestablishing vegetation on burnt areas and things, and haven't focused on bigger picture projects at this point.
Perfect. Thank you. That's it for now.
All right. Very good. So our next section of our presentation today is general practices, things that will typically happen around the mine site on a general basis, practices that we'll do overall on the site. And as we get into this, we'll see that, first of all, handling and management of soils is probably the first and foremost when it comes to reclamation activities. As we go in and recognize where our project footprint is, we want to be able to salvage the soils that are available and be able to have those available for future use in reclamation. Often on these projects, soils or growth media tends to be a premium, and you want to salvage that and keep it for use in later reclamation. In 2017, Tetra Tech, our consulting firm, was able to do a soil survey on the site for us, and they identified 9 official soil series, and 6 of those soil map units, or SMUs, of those 6, 3 were suitable and 3 were unsuitable. And the question is, well, what makes something suitable or unsuitable? And essentially anything that we can realistically gather up and salvage, we do. And the unsuitable components are things, soils that might be on slopes that are greater than 45 degrees. And the reason that those might not be suitable is, first of all, on those steeper slopes greater than 45 degrees, we typically don't see a lot of soil development there. And secondly, it's very difficult on those steeper slopes to get equipment onto the slopes that we can salvage those soils. So that is considered an unsuitable category. And then secondly, excessive rock. So if you have soils or materials that are more than 60 or 70% rock, and would have a very low likelihood of being able to propagate vegetation, those are considered as less suitable. And then thirdly, previously disturbed areas, the soils on those previously disturbed areas may not be suitable for reclamation. And so we didn't include those in the soil balance, although we'll note some of those later on in the discussion as possibilities. And in that soil salvage, we estimate 1,884,000 yards of material available for salvage. And that'll become an important number because we want to look at that number and see how much do we need for reclamation and restoration as we get into those practices. So here's a quick snapshot of all, and this map shows all of those soil map units and that were used to calculate this 1.8 million yards of material available for salvage. So now the next step is obviously going to be how much material do we need in our reclamation practices. And so these next 2 slides, I have 2 slides here that show the proposed growth media and seed bank material. That's SBM, seed bank material. This first slide is for the tail storage facility in particular. And we see there's 3 components that will be used for the tail storage facility. On the left side, this is for the upland areas of the tail storage facility, in which we're proposing to put 6 inches of growth media or soil on that. And we recognize that there's also 2 feet of development rock that will be used for a cap to cover and separate the growth media and vegetation from the actual tailings below that. In the middle and on the right, these 2 columns represent the types of and thicknesses of materials that will be used for the riparian stream and wetland corridors. In the middle, we'll use from top to bottom about 6 inches of seed bank material under or over about 6 inches of growth media. And that seed bank material is the top 4 to 6 inches of material that will salvage that would likely have more natural seed in those soils. And so we want to segregate those and be able to use those specifically for wetland seed bank as we do our restoration and reclamation activities, because those materials contain a lot of the nutrients and seed that those particular lands like wetlands need. As we go down the column, we recognize that there's stream bed material and rock armoring layer, and these don't have depths on because they'll vary a bit depending on the design and location. But that said, there is sufficient depth here, especially in this rock armor layer to make sure that we don't scour down, the stream doesn't scour down to this next layer, which is a liner layer, a GCL liner with the transition layers above and below it. And that GCL liner separates the tailings from all of the column above it, which is essentially the stream. And similarly, the column on the right is the same column without the stream bed. So we have designed in a floodplain corridor that is between 100 and 200 feet in width, and we'll see some depictions of that in a slide or two come in. But we just don't have the stream bed material in it. So this is the area that is the floodplain. It still has the seed bank material for wetlands and the growth media below that, as well as the rock armoring and the liner layer, the GCL liner. So that's what we're planning on in our reclamation closure plan and restoration plans for the tail storage facility.
Hey, Dan, this is Rob. Can I interrupt you for 2 seconds?
You bet.
On that
Thanks,
last
Rob.
slide, just wanted to clarify a little bit that the central profile there is the stream with the stream bed material does span the whole floodplain. The image on the right is just at the very margin to provide some protection. So as the stream migrates within that 100 to 200 foot wide corridor throughout the floodplain, which it can do so freely, it doesn't, at the very edge of that floodplain corridor is where there's additional rock armoring to prevent it from migrating off of the floodplain corridor.
Thank you,
Rob. The stream bed material spans the whole floodplain.
Yep. I appreciate that. Good clarification. All right. As we go into off of the TSF and other areas like the DRSFs, the Development Rock Storage Facilities, and other upland areas, very similarly, these columns represent the seed or the soils, cap and cover materials. On the areas like the development rock storage facilities, we are intending to put 12 inches, a full foot of growth media over that development rock to help establish vegetation. And on development rock storage facilities like Fiddle, DRSF, where we have Fiddle Creek, we have a very similar situation where we have a combination of growth media and seed bank material, rock armoring, and a layer of liner, a GCL liner that separates the development rock from the upper materials to transport those waters across it. And also other miscellaneous areas such as haul roads, we're planning on putting 6 inches, half a foot of growth media above the regolith, which would be the materials used for the roads and stuff. Those roads will be obliterated and fills pulled back into cuts and scarified so that those hardened surfaces will allow better plant growth. So now that we understand what needs to go back on in the reclamation, closure, and restoration processes, we can do a soils mass balance. And remember this value of 1.8 million, we are estimating that we're going to need 1.91 million cubic yards of material to do this reclamation and closure, which indicates then that we have about 34,000 yards of deficit. And right off the cuff, if you're thinking about wheelbarrow loads, that's a lot of wheelbarrow loads. But in comparison to the salvage, that's only 1.8%. and that's a very small percentage and really within the margin of error of these estimates. But that said, we still want to find ways to be able to overcome that deficit, and we'll talk about those in a minute. So keep that in mind. The 34,000 yards is a deficit that we need to find that volume of growth media for. It's notable that we have 9 different growth media seed bank material stockpiles, and we also are planning on live handling 150,000 bank cubic yards of that material, meaning that live handling is that when you salvage it, instead of putting it in a stockpile for some period of time, it goes directly to the location in which it will be used for reclamation and placed and planted and used in reclamation. So whenever possible, we like to do that. It helps preserve the nutrients and seeds in that material. Some options that we're looking at to facilitate that deficit or to overcome that deficit, in addition to generating composting, which we'll talk about in a minute, is a couple things we're looking at. Salvage cover from previously reclaimed areas. Now, we noted that previously in the presentation that we didn't add in those previously reclaimed areas that were within the footprint of the mining disturbance. So we'll have to evaluate those and test them and make sure they're suitable for reclamation, and that's one possibility to handle at least a component of, maybe not all of, the 34,000 deficit. There's also a possibility of utilizing some growth media salvaged from the burnt log route, in that there's excesses, there may be excesses of growth media there that could be used to help facilitate that 34,000 deficit. And thirdly, we're looking at other volumes of material that could be used to supplement and enhance the volumes of the existing growth media, such as alluvial lithologies out of the Hanger Flats pit, or glacial till out of the yellow pine, the upper cuts of the yellow pine pit. So those are several possibilities that will be evaluated for the deficit, overcoming that deficit. Let's talk about composting really quickly here, because that's a main thought and component of this and is built into our plan. There's opportunities to build soil by composting programs. We can focus on adding a volume as well as improving the growth media quality. And our reclamation and closure plan has in it the utilization of 10 tons per acre of compost to blend with the growth media to add nutrients. And we can also add additional composting for volume. We mentioned before that we'll evaluate materials that were previously disturbed that might be adequate and appropriate to use as volume amendments to overcome the 34,000, or to be used with composting so that they can, the composting material can be added to those and create a nutrient-rich growth media. And as far as feedstock for composting, we're looking at on-site materials from the worker housing facility, as well as off-site materials that could be hauled in and used for composting. So let's talk about planting prescriptions. We talked about the basis for plants and vegetation with the growth media and the seed bank material. So let's talk a little bit about now what plants, what vegetation are we planning on using? And you'll see on this map on the right here there's various colors and hatch patterns. And what the Reclamation and Closure Plan has dutifully done is gone through and looked at the different aspects, shading, sunlight, water availability, slope angles, and determined where planting of different species of native species is most appropriate and will have the highest success rate. And you'll see that there's both colors and hatch patterns here on this map showing the various locations of the different plant types. And again, these are, the goal is to establish self-sustaining grasslands, shrubs, and tree communities of native species. So we're looking at those native species as the primary plant sources here. The types of vegetation, we're planning on upland general sites, upland cool sites, wetlands and streams, of course, have more specific vegetation types. And of those upland vegetation classes, there's, and this is where the map shows this, it's somewhat hard to read this key that is in the Reclamation and Closure Plan, but there is the cool aspect grasslands, the general grasslands, trees and shrubs, as well as parkland trees and shrubs, and then basic shrubs. So there's a whole variety of these 5 different classes that we're looking at establishing, reestablishing vegetation through the mine site. All right, let me back up one before we go on to specific closure practices. Let's take some questions. Do we have any questions, Shelley?
We do, Dan. Please explain what you mean by GCL and how it functions.
GCL. A GCL is a liner that is, it's a clay liner with a geotextile fabric associated with it to keep it intact. And it functions. It comes in a dry format. It's a dry clay, and it's rolled out in sheets and overlapped at the edges. And essentially, when moisture hits that clay liner swells and becomes a very low permeability liner. And there was GCL also used in last week's presentation about the tailed storage facility liner. That was used in that aspect as well. This is specifically, we're using that to help separate and keep surface waters in streams on the surface as they cross facilities like the Yellow Pine Pit. So we don't want those waters to rapidly infiltrate into backfill material, and so those liners are important to keep those waters separated and flowing in the right areas for which they're designed to flow. So that's a geosynthetic liner, GCL.
Perfect, thank you. That's it for now.
That's it for now. All right, very good. Happy to take questions if folks have questions. Our next section is with respect to more specific closure practices. And as we get into this, our reclamation closure plan and restoration plans, we have in those specific facilities closure practices for the following, and this is, I'm going to just rifle through these real quick. A tailed storage facility, Hanger Flats DRSF, backfill of Yellow Pine Pit, the Fiddle DRSF, West End Pit, Burnt Log and Thunder Mountain Roads, the Fish Passage Tunnel, exploration related sites, underground exploration, the plant site and the worker housing facility, haul roads, internal access roads and other compacted sites, substations, switch gears, electrical transmission lines, water, and sediment retention structures. So each of these in the reclamation and closure plan have specific practices that will be implemented to close and restore and reclaim these facilities. There's not enough time in the presentation to go through and show you examples of all of these, so I've picked a few examples to show you how these more specific facilities closures will happen. And the first one I want to go into is the tail storage facility. How will that more specifically happen? And pardon me, as this becomes consolidation is completed and the TSF is available for reclaim and restoration, the first thing we'll do is regrade the Hanger Flats DRSF. And we recognize that out here on this map on the right side, the face of this development rock storage facility will regrade to some degree, and in doing that, our objectives are to be able to get growth media on them and get the surface water controls on the DRSF to a point where the water will not run directly down the face and make rills, but it will be captured and transported off this DRSF face in a controlled way. Also, we'll cover the tail storage facility, this more central and left portion where the actual tails are, with 2 feet of cap material, and that cap material will be derived from the DRSF adjacent to it. Then we'll cover the TSF and the Hanger Flats DRSF with 1 foot of growth media, and we talked about those columns of what will go into the uplands and also the riparian and stream and wetland areas. And then we'll implement the stream and wetland restoration plans. And so my next slide, I want to go into that stream and restoration plan, but a little side note as we get into that, we recognize that stream reclamation is a little bit different than stream restoration, and these plans that have been developed are true restoration plans. And we recognize that reclamation, it's designed and targeted at stabilizing and making things stable, static, with little to no change, and it likely doesn't mimic natural conditions. Whereas the goal and design, the goals of our designs are to restore, make things naturally dynamic, deformable, resilient, so that they do mimic natural conditions. And these are both photos of Meadow Creek area. So on the TSF, this is a quick snapshot of just one of the reaches of the stream design, the restoration design. We talked about the floodplain previously, and we can see in the black, the 2 black dashed lines, this 1 to 200 foot corridor that is designed to be the floodplain. As was pointed out, this will be completely lined with the GCL, so that the tails are completely separated from the waters of Meadow Creek in this reach, as it will be through all the reaches across the TSF. A lot of design work has gone into this to make these resilient, dynamic streams. You can see the sinuosity of the stream. It's been calculated based on gradients and flow patterns. This stream is designed to be to allow migration of stream, avulsion, scour, and deposition of the stream, so it will act naturally like a live stream will, and provide the natural habitats that a live stream would. Similarly, we also have wetland planning prescriptions and layouts for the same reach of this restored channel in Meadow Creek across the TSF, in which the wetland prescriptions have been designed out to complement the stream design in this corridor, this floodplain corridor, again on top of that that liner to keep the water separated from the tails. So that's one example of a specific design. Another one is the Yellow Pine Pit. And this one's a pretty big component of our project, in that not only is it a larger chunk of area, but we're trying to reestablish the east fork of the south fork of the Salmon River across the pit in a natural way that will allow the river to be dynamic for perpetuity, and allow fish passage, volitional fish passage through that river, which of course currently is not available. We recognize that the specifics of this are, first of all, that the surface is really controlled by the needs of the river right here, meaning that, excuse me, meaning that in order to get the gradients needed for the stream to have both long-term perpetuity and flexibility in the controls that a stream needs, but also to allow fish to migrate both upstream and downstream for adults and juveniles, that river has to have a gradient to it that will allow all those things. And so that the river corridor stretches out a little bit longer and curves around a little bit more than it might if we were just making a straight shot out of it. But that's a necessity to the criteria of the design of this particular reach. Mine operations will backfill this pit, and we see some of these orange contours on what that pit backfill will look like. So mine operations will provide the backfill and get that to near final grade. There will be some remaining high walls, as we see over on this left side of the map, and we'll see in a depiction in a minute. But for the most part, the high walls are covered. As we build up from the stream elevation, we have buildup of backfill above that stream level, and that helps also to conform and make it conform to natural topography and help it look like a more natural topography. We have a public access road that will be designed in, and we also have a mine access road that will be maintained, as we see on this photo, to allow monitoring and maintenance of the west end area. Cover with 1 foot of growth media, and then of course implement the stream and wetland restoration design. And let's jump into that again. Here is the stream design for the section, the reach of East Fork, South Fork, Salmon River across the across the Yellow Pine Pit. And you'll notice here that this is overlaid on a photo of the existing conditions. So in the background here, this darker gray area is the existing Yellow Pine Pit Lake. So that gives you some perspective on where this will ultimately be as the stream comes in and all the sinuosity of the meanders and such come through the pit. And as we also have other streams coming in, like Midnight Creek and Hennessy coming into the picture in this particular reach. Very well designed. Again, it's designed to be dynamic and be able for the stream to migrate, scour, and do deposition as a natural stream would. And again, We have Tetra Tech has designed out wetland areas fit very nicely in this corridor. Again, the floodplain corridor is aligned in the black dashed lines here. So this is where we get to the wider reaches, the 200-foot reaches of the floodplain, and we have wetlands and off-channel habitat built into these designs as well. So very well thought out designs for the stream and wetland corridors of this specific reach, as well as the other reaches of the East Fork, South Fork of Salmon River. This is, as a lot of people recognize, this is a photo of existing conditions today. And we compare that to, again, 1938 is when the last time fish came through here due to the pit wall. And we look at this now compared to what the plan is going to restore the stream as. And so these particular stream depictions are right from the design that we just looked at, and we'll be able to permanently restore fish passage. Will allow those fish to get upstream to the enhanced habitat for spawning and rearing that we've previously talked about. So again, we see these areas where there's a little bit of pit wall, but we have heaped up the backfill as much as we can in areas along the high walls and reestablish the stream through here. So those are examples of specific design practices that will be implemented in this particular area. Let me back up here. This is a good place to stop. We're going to transition, not transition, but we'll talk about some other site-specific facilities as well. But is there any questions at this point?
We do have one.
Okay.
What are the plans for storm water management beyond the 2020 year plan?
Stormwater management, that's a really good question. So stormwater management will evolve as we go from construction to operations and reclamation and closure. And when I say evolve, what I mean is that as needs increase, the stormwater management will have additional contact water ponds, and we'll have increased levels of water treatment. And as those needs start to diminish, we'll also have a reduction of those ponds and treatment as those needs diminish. But they'll extend those contact water ponds and water treatment will extend through closure to a point where they're no longer needed, and ultimately beyond year 20, the envision is to have a site that doesn't have anything but possibly a water treatment plant. So all of the run on water should be and is designed to ultimately naturally go to the lower parts of the valley and end up in the streams and become part of the waterways. And that's only after we have monitored and know that those waters are clean and appropriate to be flowing down to the streams. So it will evolve over time, but ultimately the intent is to get all of the meteoric water and such to report to its natural locations in streams and wetlands to support the vegetation and aquatic life in the valley. I hope that answers that question.
Perfect. Thank you, Dan.
Any other questions?
Not right now.
Okay. So there's another few examples of of these more facility-specific practices are the power transmission line, post-construction reclamation. That means, hey, we've got to put some roads in and some tensioning areas in and some laydown areas to help facilitate that construction. But post-construction of that power line, we'll go back and do reclamation work on the construction access roads that aren't needed for maintenance any longer, the laydown yards and the tensioning areas. So those impacts will only be short-lived because the construction of that power line is a very short project. Post-project reclamation, the new portions of the power line will be removed and the new portions of the access roads used for maintenance throughout the life of those new portions will be reclaimed and removed and obliterated and reclaimed. The other large linear component of the project is the burnt log access route. Through that construction process, growth media will be salvaged, and post-construction reclamation, meaning that areas that were used to help with the construction will be reshaped, and growth media will be applied, and vegetation put on those areas. Post-project, the new roads will be obliterated, meaning that the fill material will be pulled back up into cuts and reshaped to blend into natural topography, and then we'll use growth media to reestablish vegetation on those areas. And then the areas of the road that were widened will re-narrow those roads to get them back to what the existing burnt log road is its current width. So we'll reduce those and apply growth media and vegetation application as well. So that's a quick look at the specifics on the burnt log route. One of the questions that often comes up is, how do we understand if we're achieving what we want to? What are the performance standards and the maintenance of our project in reclamation and closure? And certainly the goal is to demonstrate that we're meeting the CFRs and the IDAPA regulations around our reclamation and closure plans. So we want to make sure we're meeting those standards. As far as the process, we are intending to have an integrated process so that we're compliant with site monitoring and adaptive management. And of course, the U.S. Forest Service, Idaho Department of Lands, and Midas Gold will formalize specific reclamation monitoring plans and performance standards. And those, right now, we put forth a reclamation and closure plan. And of course, public comment will help us with that, which we're in that process right now. And we'll develop from that in future months a more formalized standards and performances to make sure we're meeting that. And ultimately, the performance standards are going to be the tape measure by which the federal and state agencies will measure and determine whether bond release is appropriate and when a bond release is appropriate. So we're at our last part of our presentation today. In summary, reclamation, we have 81% of our disturbance is planned to be reclaimed. That's 1,539 acres. Concurrent reclamation, meaning during the mining process and the operations process, we'll reclaim 457 of those acres. And as we noted in our material balance, we'll place almost 2 million yards of growth media and live handle 150,000 of those. we're from the PRO, which is alternative 1 in this plan, in a reclamation and closure plan, we've actually increased our growth media depths. Everything in the PRO alternative 1 was a 6-inch growth media depth, and through the additional work that we did for the Mod Pro or alternative 2, we've been able to establish a 12-inch growth media depth over some of those more specific facilities like the DRSFs and the TSF. So that's a quick summary as well. And it brings us to the end of the hour and the end of the presentation. So other questions? Anything that we have, Shelley?
We don't have any questions at this time, but I did want to open it up to Kirk or Walt. Did you have anything to add before we end the presentation?
This is Walt Varing. I don't have anything to add. Dan, great job.
Thank you.
Yeah, I would agree. I think we've got bases covered, but unless there are questions.
Wonderful. Well, I appreciate everybody taking the time today to listen to our reclamation webinar. Again, we will be doing, we have one. So while we have you online, Dan.
Okay.
Could you explain more on the bond release process?
Yes. The bond release process would be a process, excuse me, in which the proponent, in this case Midas Gold, would request of the state and federal agencies a release or a reduction of a bond amount, and we would have to show that we're meeting the performance standards required, so that essentially we're proving that the reclamation and restoration processes that were in our plan are being met, and that it is a self-sustaining, stable environment. And so the state and federal agencies would evaluate that and determine if indeed that is the case. And if it is the case, then they, the state and federal agencies, have the ability to release a portion of a bond or reduce the amount needed for a bond. So for instance, a bond, a portion of the bond may be for resloping and putting growth media and reestablishing vegetation, and the proponent may request release for that dirt work component of those. And the agencies can say, okay, you've done the dirt work appropriately, but we're still waiting on the vegetation. There may be maintenance that you need to do on the vegetation. You may need to go back and replant. You may need to do something different on the vegetation to get it to go. So we're not going to release that vegetation component, but they may recognize that the dirt work component has been successfully completed. So they have that flexibility to release portions of a reclamation bond. Ultimately, the proponent, Midas in this case, would want all of the bonds released so that their liabilities for perpetuity are released. And in order to get to that, it's our obligation to get the reclamation, closure, and restoration done as quickly as we can, and as well as we can, because we want it to be established and self-sustaining and stable, so that when we do ask for a reclamation bond release, that it is indeed ready for release, and we're not dragging everybody through a bunch of hoops for nothing. So that's part of the process. I guess it was probably more long-winded in that than I should have been, but that's reclamation bond release process in a nutshell.
So last question, since it's along the same lines, does the company have appeal rights?
Does the company have appeal rights? I'm guessing this is with respect to bond release.
Correct. For bond release, correct.
Yeah. Yes. Within the IDAPA, the Idaho rules, there is an appeal process in which the proponent can appeal a negative decision to the land board, I believe is what it is, the Board of Trustees of the Department of Lands. And the details of that process I don't have off the top of my head. So it would be good to answer that question, to go to those IDAPA rules and look those up. But there is an appeal process, but ultimately it goes back to the proponent to show the reclamation, closure, and restoration are meeting the performance standards.
Wonderful.
Good questions. Good
Thank
questions.
you. Thank you, Dan. Okay, so we've kept you guys about 5 minutes over schedule, so I'm gonna go ahead and close it out here. Thanks again for joining us today. Next week, we'll have a webinar on water quality next Thursday with Dale Kerner. And we will also have on Tuesday a Stibnite Gold Project 101 overview with Mackenzie Lyon, our VP of External Affairs. If you have any other questions that come up after this webinar, please feel free to shoot those over to us. We're always happy to answer them. And of course, if you guys have not sent in your comments, support comments, please do so. You can go over to www.countidahoin.com to get that started. Thanks again, everybody, and have a wonderful day.
Bye, Shirley. See you, Dan.